Is it audible now? Hello? Am I audible now? Next, problem 3. Find the evolute. Find the evolute of an ellipse. Find the evolute of an ellipse x square by a square plus y square by b square equal to 1. So I have to find the evolute of an ellipse. Solution. By our observation, we know that evolute of an ellipse is an asteroid. So finally, I have to get equation of this form. X power 2 by 3 plus y power 2 by 3 equal to some constant power 2 by 3. So that you should keep in your mind. So given x equal to a cos, given x square by a square, x square by a square plus y square by b square equal to 1. You have to consider the parametric form. So we have x equal to a cos t and y equal to b sin t. Yes, this is the parametric form for ellipse. Now from this, dx by dt equal to minus a sin t and dy by dt equal to b cos t. Dy by dt equal to b cos t. Now y1 equal to, that is dy by dx equal to, by chain rule, this is dy by dt by dx by dt, that is b cos t by minus a sin t. So y1 is minus b by a cot t. y1 is minus b by a cot t. Now y2, we have to differentiate this again with respect to x. Minus b by a into derivative of cot theta, that is minus cosecant square t, into derivative of t with respect to x, that is dt by dx, that is nothing but 1 by dx by dt. So y2 will be minus into minus plus b by a cosecant square t into 1 by dx by dt, that is minus a sin t. But 1 by sin is cosecant. So get y2 to be y2 equal to minus b by a square into cosecant cube t, minus b by a square into cosecant cube t. So I got y1 and y2. Now x bar equal to x minus y1 into 1 plus y1 square by y2. Right, now let us substitute for x, y1 and y2. So here x is a cos t. Yes. So x is equal to a cos t. So I got x bar to be a cos t minus, here minus b by a cot t. Okay, I'll write here minus b by a cot t into 1 plus y1 square, that is b square by a square cot square t divided by minus b by a square cosecant cube t. So let us put bracket for this. Now it will be x bar equal to a cos t minus into minus into minus. I have three negative signs. So odd number of negative signs leads to negative again. B by a cot t into this one. Taking this term to the numerator, we get minus n I have already taken, a square by b into sine cube t times this term I have to keep as it is, 1 plus b square by a square cot square t. So x bar equal to a cos t minus t, b get cancelled, here one term a cancels and another one remains here, into cot t, I'll write sine first, sine cube t cot t times 1 plus b square by a square cot square t. Let us write all the terms in terms of sine and cos only. You have to write this cot in terms of sine and cos. So actually this will be x bar equal to a cos t minus a sin cube t into cos t by sin t times 1 plus b square by a square into cos square t by sin square t. So this sin t one term cancels with this, so we get x bar equal to a cos t minus a sin square t into cos t times 1 plus b square by a square cos square t by sin square t. So x bar equal to a cos t minus, multiplying this term inside, minus a sin square t cos t minus a sin square t cos t into b square by a square cos square t by sin square t. Now a one term cancels with this, and sin square t get cancelled. So remain with cos t into cos square t, right? Okay, this will be x bar equal to a cos t minus ah yes. In these two, we can take a cos t as a common factor. A cos t, if you take outside, you get 1 minus sin square t. Observing that, I am taking a cos t as a common factor in the first two terms. Here minus b square by a into cos cube t. B square by a into cos cube t. Now it is x bar equal to a into cos t into 1 minus sin square t is nothing but cos square t. So cos t into cos square t, cos cube t minus b square by a cos cube t. So get x bar to be taking cos cube t outside and simplifying terms inside. You get a square minus b square by a into cos cube t. A square minus b square by a into cos cube t. That is about x bar. Now I have to get y bar. Now I have to get y bar. So that I'll discuss here. Y bar equal to formula first I'll write 1 plus y plus 1 plus y1 square by y2, right? Now y bar equal to y means b sin t, y means b sin t plus 1 plus y1 square, that is b square by a square cot square t divided by y2. y2 is minus b by a square cosecant cube t. Now y bar equal to b sin t plus, okay, I'll get minus n, right? So taking this to numerator, minus a square by b into 1 by cosecant cube t, that is sin cube t into this term I'll carry as it is 1 plus b square by a square cot square t. Now y bar equal to b sin t minus, let us multiply these terms inside, and then also write this cot in terms of sin and cos. So it will be minus a square by b sin cube t minus a square by b sin cube t into b square by a square into cot square t, that is cos square t by sin square t. Yes. Now here this a square get cancelled with this and b one term cancel with this and sin square t cancels with this and one term of sin is remaining there. So get y bar equal to b sin t minus a square by b sin cube t minus here b, only b is remaining, sin t into cos square t. Now here I have b and here also I have just b. Now looking into these two, I can take b sin t outside. So it will be y bar equal to b sin t times 1 minus cos square t minus a square by b sin cube t. So y bar equal to b sin t into s sin square t, right? It will be b sin cube t minus a square by b sin cube t. So this we can write as, see, actually it will be b square minus a square by b sine cube t. But to have terms common, see here I have a square minus b square by a, so I'll write this as y bar equal to a square minus b square by b sine cube t. Okay, negative sign, minus a square minus b square by b sine cube t. So I got x bar and y bar. I'll rewrite y bar here. So y bar I got minus a square minus b square by b sine cube t. Now we need to eliminate t between these two parameters. I mean between these two equations. Sorry. Now from this I can write ax bar equal to, see, cos square t plus sin square t is 1. I'm going to use this identity here. To use this identity, I have to get an expression for cos square t from this, and then expression for sin square t from this. Then add those two. See, ax bar equal to a square minus b square cos cube t. And similarly here, by bar is equal to minus of a square minus b square sin cube t. Rise power 1 by 3 on both sides. So ax bar whole power 1 by 3 will be equal to a square minus b square whole power 1 by 3. For our convenience, we may assume a square minus b square is greater than or equal to 0. So cos t. And here by bar whole power 1 by 3 is equal to minus of a square minus b square whole power 1 by 3 into sin t. But we have sin square t plus cos square t is 1. So I have to square on both sides. So I'll get ax bar whole power 2 by 3 is equal to a square minus b square whole power 2 by 3 cos square t. And similarly here, by bar whole power 2 by 3 is equal to squaring on both sides. This negative sign vanishes. So get a square minus b square whole power 2 by 3 into sin square t. Now adding these two expressions, adding above two expressions, we get ax bar whole power 2 by 3. I'm just adding left hand sides of both the equations. Ax bar whole power 2 by 3 plus by bar whole power 2 by 3 is equal to a square minus b square, right hand sides of both the equations, cos square t plus by bar whole power 2 by 3, sorry, it is a square minus b square whole power 2 by 3 sin square t. So adding these two, get finally ax bar whole power 2 by 3 plus by bar whole power 2 by 3 equal to a square minus b square whole power 2 by 3 into 1. That 1 is nothing but cos square t plus sin square t. So this is of the form, if we take capital X to be ax bar and capital Y to be Py bar and capital A to be A square minus B square, then this takes the form x power 2 by 3 plus y power 2 by 3 equal to constant power 2 by 3. So this represents asteroid. So this proves that evolute of an ellipse is an asteroid. In a similar way, you can determine evolute of hyperbola. That is similar. Next, that you can take as exercise. Find the evolute of an hyperbola. Get asteroid only. Finally, show that the evolute of the cycloid x equal to a times of theta minus sin theta and y equal to a times of 1 minus cos theta is another cycloid. Solution. First, let us consider the given thing. It is already in parametric form, so nothing to worry. X equal to a times of theta minus sin theta, y equal to a times of 1 minus cos theta. Right? Now, differentiating, this will be dx by d theta equal to a times of 1 minus cos theta and dy by d theta is equal to a sin theta. Right? Now, by chain rule, we have dy by dx to be, that is dy by d theta by dx by d theta, that is a sin theta by a times of 1 minus cos theta. A get cancelled, sin theta by cos theta, I have to use half angle formula. 2 sin of theta by 2 into cos of theta by 2 by 2 sin square of theta by 2. So I get dy by dx, that is y1 equal to sin cos by sin, right? That is cot of theta by 2. Now d square y by dx square equal to, that is y2 equal to derivative of cot minus cosecant square of theta by 2 into 1 by 2 into d theta by dx, that is 1 by dx by theta, d theta, that is 1 by a into 1 minus cos theta. So y2 equal to minus 1 by 2 into cosecant square of theta by 2 into 1 by cos theta, that is 1 by 2 sin square of theta by 2. But 1 by sin square of theta by 2 is cosecant square of theta by 2. So y2 will be minus 1 by, here a is missing, right? Yes, minus 1 by 4a into cosecant power 4 of theta by 2, or you can write y2. It is always easy to easy if I write the expression in terms of sin and cos. Minus 1 by 4a sin power 4 of theta by 2. Both are correct. Now let us proceed to determine x bar and y bar. Now x bar equal to, I have to write the formula x minus y1 into 1 plus y1 square by y2. So x bar will be 1 plus y1 into. So what is y1? Cot of theta by 2, right? So x minus cot of theta by 2 into 1 plus cot square of theta by 2 divided by y2. y2 is minus 1 by 4a. Let us write in terms of sine only. Sine power 4 of theta by 2. So this will be x bar equal to x minus, okay, minus into minus, it will be plus cot of theta by 2 into 4a sine power 4 of theta by 2 into this term 1 plus cot square of theta by 2, that is cosecant square of theta by 2. Writing everything in terms of sine and cos only, you get, okay, x means, I have to write that thing, x means a theta, a times of theta minus sine theta, that also I have to write, x, that is a times of theta minus sine theta plus here cot theta by 2, okay, let us write 4a first. Cot theta by 2 is nothing but cos of theta by 2 divided by sine of theta by 2 into sine power 4 of theta by 2, let us write it as it is, into cosecant square of theta by 2, that is 1 by sine square of theta by 2. So from this you get sine theta by 2, sine square of theta by 2, that is sine cube of theta by 2, that cancels with this. So we just remain with x bar equal to, I'll multiply this a inside, a theta minus a sine theta plus here 4a sine of theta by 2 into cos of theta by 2, right? So x bar equal to a theta minus a sine theta plus, here this 4 I can write as 2a into 2. So 2a into 2 sine of theta by 2 into cos of theta by 2, that is sine theta. So x bar equal to a theta minus a sine theta plus 2a sine theta, that is a times of theta plus sine theta. So I got x bar. Now similarly we need to compute y bar. Now y bar equal to, the formula is y plus 1 plus y1 square by y2. So y bar equal to y plus, so what is y, a times of 1 minus cos theta plus 1 plus y1 square, so that is 1 plus cot square of theta by 2 divided by y2. y2 is minus 1 by 4a into sine power 4 of theta by 2. So now it is y bar equal to a minus a cos theta minus 4a into sine power 4 of theta by 2 into cosecant square of theta by 2. Okay, it will be y bar equal to a minus a cos theta minus 4a into sine power 4 of theta by 2 into cosecant square means 1 by sine square of theta by 2. So we get this get cancelled with this one. So I'll get y bar to be y bar to be a times a, okay, a minus a times of cos theta minus 4a sin square of theta by 2, right? So this sin square of theta by 2 I can write as 1 minus cos theta. That is very important here. You have to remember that on that point. So a cos theta minus 2 OSS 2 sin square of theta by 2. So it will be 2a into 1 minus cos theta. Now multiplying terms inside, it is a minus a cos theta minus 2a plus 2a cos theta. So now it becomes y bar equal to minus a plus a cos theta, or y bar equal to minus a times of 1 minus cos theta. So I got x bar to be a times of theta minus theta plus sin theta. Earlier we had x to be a times of theta minus sin theta, right? And earlier we had y to be a times of 1 minus cos theta. Here I got minus a times of 1 minus cos theta. So from this you can conclude that hence evolute of an ellipse, oh sorry, evolute of a cycloid is itself, okay, is another cycloid.